Hello students, I hope you are all well. So, warm wishes on New Year to all of the students. A new year give us all a chance to achieve whatever we could do in the last year. So, in the last video, we just completed our meta, metallurgy exercise 7B, and today we will be discuss the exercise 7C and 7D. So this class will be more interesting and fascinating. Stay with me and enjoy this class. Let's start. So in this first question, we saw state the position of aluminium in the periodic table. Okay, we know all of us know about periodic table. This is some kind of some tables, okay, which is denote the position of any kind of matter, okay, gases, noble gases, and alkali earth metals, okay. No, we know about this. So in this periodic table, the position of aluminium, definitely it is a metal, so this is the group 3A, position is 13 and period is 3. Very easy question, students, and listen carefully. The periodic table is the most important thing in your syllabus. Please study it very carefully, because uh, chemistry is all about this kind of stuffs and this kind of elements, so you know about their positions and their value in this group. Okay, so question number two, give the chemical name and formula of the main ores of aluminum, iron and zinc. Okay, so name of the aluminum in bauxite, chemical name. What is the chemical name? Chemical name is hydrate aluminum oxide, Al3O3 2H2O. This is the main core ingredient. Is the name of a ore is bauxite, and another one is chirolite, sodium aluminate oxide, Na3AIF6. Okay, this is the chirolite or sodium aluminum oxide. Ore of iron, we know about this iron, I guess so. This is the name is red hematite. Okay, chemical name anthrodus ferrous oxide. The formula is Fe2O3, and the another one is brown hematite. Red hematite contain more iron or iron element inside it, and then next one is brown hematite, hydrate ferric oxide, 2Fe2O3, 3H2O. Okay, number B. Which impurities are present is bauxite? Bauxite are contain uh, approx approx is better to say, approximately 60% aluminum oxide, the rest being sand, ferric oxide and titanium oxide. Okay, approx or approximately, yes, the right pronunciation is approximately. Approximately 60% aluminum oxide and rest beginning to the sand and ferric oxide and titanium oxide. Red mud contains of ferric oxide, sand, etc. left after bauxite dissolved in NaOH, forming sodium aluminate, and it's removed by filtration. Clear, guys? Is removed from filtration. What is the red mud? How is removed? Okay, red mud consists of ferric oxide. Red color denote to the sand for this oxidation process. So oxide, sand, etc. left after bauxite dissolve in NaOH, forming sodium aluminate, and it's removed by filtration. Ore of aluminium. Which is ore of aluminium? Oh, this is the mispronounced. Not matter. Okay. So here we have some certain question about this number 2. Question number 3. In order to obtain 1 ton of aluminium, the following inputs are required: 4 ton of bauxite, 150 kg of sodium hydroxide, and 600 kg of graphite. The aluminium compound in bauxite is aluminium oxide, and the main impurity is iron 3 oxide. Aluminium is obtained by the electrolysis of aluminium oxide dissolved in cryolite. When bauxite is treated with sodium hydroxide solution, what happens to? Okay, if bauxite treated with sodium hydroxide solution, what happens to? The aluminium oxide, the iron oxide. Name the process used to the purification of bauxite. Write the equation of the action of a heat on aluminum hydroxide. Write the formula of uh, cryolite. Write down the word which correctly completes the following sentence: by dissolving aluminum oxide in cryolite, a conducting non-conducting sodium is produced. Why is so much graphite required for the electrolysis process? Write the equation for the reaction which take place at cathode. What is cathode made up of? Okay, the solution is, the first one is when bauxite is treated with sodium hydroxide solution, what happened to the aluminum oxide, the iron oxide. So the first one, aluminum oxide dissolve in sodium hydroxide and form sodium metal aluminate, leaving behind insoluble impurities consists of ferric oxide, which is removed by the filtration. Okay, like as Al3O3, 2H2O, 2NaOH. So this reaction will be 2NaAlO2 plus 3H2O, 2Al plus N2 plus, the reaction will be 2AIN. Okay, 2Al plus 3H2O, Al2O2, 3H2, 2Al plus 6HCl hydrochloric acid is 2LCl3 plus 3H2. This all kind of this the removal filtration process. Okay, and this is the 2L plus 2NaOH plus 2H2O, 2NaLO2 plus 3H2O, H2, sorry, hydrogen, 2H2. The process used to the purification of bauxite, ठीक है से, is Weir's process. Weir's process. Action of heat on aluminium hydroxide. 2LOH3 heat, applied heat 1 degree centigrade, 1000 degree centigrade, Al2O3 plus 3H2O. Formula of cryolite is Na3AIF6. It is a very important one, so note down this one. Formula of cryolite is Na3AIF6. By dissolving aluminum oxide in cryolite, a conducting sodium is produced. Number 1. Number 2. Thick graphite rod are used as a anode. Okay, the positive one. The anode has to be replaced from the time to time as it gets oxidized by evolved oxygen. Okay, reaction at the cathode, 4Al3 plus 1,2E minus 4Al, and the cathode is made of carbon. And cathode in this electrolysis process, sign negative one. Okay, the cathode is made of carbon. So the important thing, cathode is made of carbon, and here the anode is made of thick graphite rods. Okay, so let the next one. Okay, question number 4. Aluminium is extracted from the cathode ore bauxite. Sorry, chief ore bauxite. The ore is first purified and then the metal is extracted from by the electrolytic reduction. Electrolytic reduction. Yeah, right. The right three valence equation for the purification of bauxite. Okay, name a chemical used for dissolving aluminum oxide. In which state of subdivision is the chemical use? Write an equation for the reaction. So students, here we see name of a chemical used for dissolving ammonium oxide. In which state of subdivision is the chemical used? Write an equation for the reaction which take place at the anode during the extraction of aluminum by the electrolytic process, and mention one reasons for the use of aluminum theorems, aluminum thermite welding. Okay, so the number one is, oh my god, yes, that was. So write three valence equations for the purification of bauxite. Okay, so number one is the balance equation for the purification of bauxite is Al2O3 2H2O plus 2NaOH 2Na NaAlO2 plus 3H2O NaAlO2 plus 2H2O NaOH plus AlOH3 2AlOH3 applied heat in 1000 degrees centigrade Al2O3 plus 3H2O. Chemical used for dissolving aluminum oxide, uh, sorry, fluorspar and হচ্ছে কাইলোলাইট, ওকে, কায়রোলাইট, ক্রিওলাইট, ফিলাসপার and carolite, alumina, alumina 20% and carolite 60% and fluorspar, uh, fluorspar 20%. Yeah. And the next one is at anode Al 3E electric discharge minus and Al3 plus. Okay, so aluminum is a good reducing agent used for thermite, ठीक है, welding. Thermite welding is use aluminum because it is good reacting reducing agent. Okay. Okay, question number 5. A to F below related to the source and extraction of either zinc or aluminum. Bauxite, bauxite, coke, kyrolite, fourth flotation, sodium hydroxide solution, zinc blend. Write down the three letter each of the four above list. Okay, to zinc aluminum, fill the blank using the most appropriate word from A to F. The ore from which aluminum extracted must first be treated with so that pure aluminum oxide can be obtained. Pure aluminum oxide is dissolved in to make a conducting solution. Write the formula of kyrolite. Okay, this the solution is number one. Okay, number one is write down the three letters from the above of relevant to the zinc. Okay, zinc use zinc blend, float flotation, coke. Okay. Coke is a reducing agent. Okay, and the next one aluminium. Ba aluminium exactly. Kyrolite, bauxite, sodium hydroxide solution. You know about this. The ore from the aluminum is extracted must first be treated with sodium hydroxide solution so that pure aluminum oxide can be obtained, and pure aluminum oxide is dissolved in chirolite to make a conducing solution from of chirolite is Na3Alf6. Okay, the next question is explain with reasons. In the electrolytic reductions of aluminum, the graphite anode is gradually consumed, or why the anode has to be replaced in its process. Okay, the question is the electrolytic reduction is the aluminum is the graphite anode is gradually consumed, and the next one is roasting is the carried out of the sulfate ore and not on carbonate ores. Okay, carbon can reduce lead oxide but not aluminum oxide. An electrolytic reduction is done to obtain aluminum. Why food containing iron salts should not be cooked in aluminum utensils. Okay, and the natural gas other than oxygen is formed at the anode during electrolysis of fused aluminum. Why is powdered coke sprinkled on the top of electrolyte? Solution is in the electrolytic reduction of aluminum, the graphite anode is oxidized by oxygen to CO, carbon monoxide, and further forms of CO2, so it is consumed and has to replace from time to time. 2C plus O2 to CO, 2CO plus O2 to CO2. Okay, roasting provided oxygen to the convert metallic sulfides into metallic oxide and SO2, which takes place when heat in exchange of air. Carbonate is contained into oxidized by loss of carbon dioxide, which take place in the absence of air, and when heat strongly, aluminum has great affinity toward oxygen and so cannot be reduced by the carbon or carbon monoxide or hydrogen, where the lead oxide can be easily reduced to metal lead by a carbon. PbO is the sign of a lead plus carbon, Pb plus CO, carbon monoxide. Aluminum oxide is a very stable compound because of its great affinity of oxygen. It is not reduced easily by common reduction agents such as the carbon or hydrogen. Hence, electrolytic reduction is done to obtain aluminum. Aluminum comes before iron in Aluminium comes before iron in the metal activity series, so it can displace iron from iron salt. Thus, food contained iron salt should not be cooked in aluminium utensils. Okay, because aluminium comes before iron. Okay, it is metallic activity series, so it can displace iron from iron salt. Thus, food contain iron salt should not be cooked in aluminium utensils. Okay, an anode is made of carbon which get oxide in the presence of oxygen to the form of carbon monoxide, which is the natural gas. 2C plus O2 2CO. An anode is made of carbon which get oxidized in the presence of oxygen to form carbon monoxide, which is the natural gas. Okay, natural gas. Next one is the powder coke. Powder coke is sprinkled to the top of electrolyte. It reduce heat loss by radiation. It also prevent to the burning of a anode. For each substance listed below, explain the significance of the extraction of aluminum, bauxite, sodium hydroxide, chirolite, graphite. Okay, so bauxite aluminum is extracted from the bauxite ore. It contains 60% Al2O3. P number sodium hydroxide. The ore is aluminum is extracted must first to treat it with the sodium hydroxide solution so that pure aluminum oxide can be obtained. Chirolite it lower function to the temperate and the enhance conductivity. Thick graphite rods are used as a anode electrolysis reduction. Distinguish between electrolytic methods of reduction and refining. Okay, distinguish between electrolytic methods. Okay, distinguish করতে হবে আমাদের, it will be reduction and হচ্ছে refining. So electrolytic reduction, it is remove of oxide or halide for the metal oxide of highly active metals like Na, K sodium, Ca, Mg magnesium, aluminium. That's all are ingredients here, and are reduced to by electrolytic reduction of their fused states. Oxides of the metals have great for oxygen in the carbon cannot be reduced by a carbon of carbon monoxide or hydrogen. Electrolytic refining of metal is separation of the residual impurities like a Si and phosphorus. Presence of other metals and non-metals like Si and phosphorus, unreduced oxide and sulfide and metals. It depends upon nature of metal and purpose of which metal is be obtained and nature of the impurities present. Impurities metals is made anode while the thin sheet pure metal is made cathode, and electrolytic use is the salt sodium solution of a metal to be refined. And the question number 9 is give three way to which the metal zinc differs from the non-metal carbons. At least one of the difference must be a chemical differences. The three ways in which metal zinc difference of the carbon is zinc have valency 2 and carbon and valency 4. Zinc does not form hydride by carbon does CH4. Oxides of zinc are amphortics, where oxides of carbon are acidics and natural. So that's number one. The next one is number 10. Aluminium is a more active metal than iron, but suffers less corrosion. Why? Explain and give reasons why aluminium vessels should not be cleaned with powders contain alkalis. Okay, when aluminum is exposed to the atmosphere, air is contained with oxygen, and the film of a aluminum oxide is formed at the surface. The hard things adding film of a oxygen of the aluminum oxide prevent corrosion, and aluminum vessel should not be cleaned with powder contain alkalis because aluminum reacts with alkalis to produce metal aluminate. Okay, so fill in the blanks. During the during the concentration of bauxite or aluminum goes in insoluble, the soluble হবে, exactly the answer is soluble, soluble part because of its what is amphotic nature. Okay, of its amphotic nature, and in whose process pure aluminum collected at the top of the electrolytic cell. Okay, this is the true one. Fill in the blanks, and we just completed our exercise 7C. In this next video, I will be covered the 7 exercise 7D. I hope you are guys properly totally understood in this section, and this is the basic of the metallurgy. Nothing is so much difficult. If you have forget something or some extra revision, you can replay it or remind it later. Stay with me, and I will be provide you the another your topic related chapter which is come through in your semester 2 exam, reducing follow up to the reducing syllabus. So guys, I hope you are enjoying my class and stay with me. But now I will be uh, I will be there. Okay. uh, so take care yourself and goodbye. See you the next class. Thank you guys.